Hello everyone. In today's video we are going to start the next topics of mole concept that will be included in the numericals of mole concept. Those are concentration of solutions. Means how can we express the concentration of a solution. Basically the concentration of a solution is regarding as how much solute is dissolved in the solution. So it can be expressed in many ways, from which we are going to study these many ways, that is mass percent, that is represented as WW percent, mole fraction, molarity, molality, normality, ppm, and volume percent, that is represented as V by V. Okay, so without wasting the time, let's start the first topic, that is mass percent. Mass percent can be expressed as mass of solute upon mass of solution into 100. Okay, so in this case, we, as you see, that mass of solute and mass of solution, it should be in the same unit. Okay, let's take with an understand this thing with an example. A solution is prepared by adding 2 gram of a substance P to 18 gram of water. Calculate the mass percent of the solute. So simply we apply the formula, that is mass percent of P is equal to mass percent of that is mass of P upon mass of solution into 100, and both the values we have already got in the question. So it is 2 gram and 18 gram of water, but solution refers to the mass of solute, that is P, and mass of solvent, that is water. So the solution would be the sum of substance and solvent, means solute and solvent. So the total mass would come, you can see here that mass of solution is equal to 2 gram of solute plus 18 gram of solvent. Water is solvent and P is solute. So the mass becomes 20, that is 2 upon 20. Units are same, gram, they get cancelled into 100. And when we solve it, then we get the answer, that is 10%. So as you see, in this way we can solve easily the mass percent question. This is a very an easy term to express the concentration of the solution. Let's take the next term, that is mole fraction. As the name suggests, mole fraction, it is the related to the fractions of mathematical term, fractions. So by the definition, it is the ratio of number of moles. So what we consider, number of moles of a particular component to the total number of moles of the solution. Means in a solution, how many moles are present of a particular component of which we have to calculate mole fraction. Let's take an example. If substance A is dissolved in substance B, means A is solute and B is solvent, then their number of moles are Na and Nb. This also we have you can say we have assumed the values Na and Nb are the moles of A and moles of B respectively. Then the mole fraction formulas will be, the mole fraction of A would be number of moles of A upon total moles, means number of moles of A plus number of moles of B. Similarly, if you want to calculate mole fraction of B, then the formula will be changing from only at the numerator, Nb upon Na plus Nb. Let's understand this thing with a numerical. This is the formula representing composition of solution by weight percent, that is mass of solute upon mass of solution into 100%. This pic represents the mole fractions of solute and solvent, and the mole fraction of solute and solvent together on adding gives the value equal to 1 exactly. Okay, so now we are going to have an example of mole fraction, that is a substance A is dissolved in substance B and their number of moles are 3 and 7 respectively. So the mole fraction of A would be, as we have studied the formula, that is Na upon Na plus Nb, means the moles of A upon the total moles. So mole of A is 3 and total moles would be 3 plus 7 from here, 3 plus 7, that is 3 upon 10. Similarly, the mole fraction of B would be 7, the moles of B upon total moles, 3 plus 7, that is 7 upon 10. So these are the answers of mole fractions. Okay, so I think it is also a very easy topic. Okay, you can easily understand. Let's move to the next topic, that is molarity. Now it is a very important and technical term to understand. Molarity, it is represented by capital M. What is molarity actually? It is the number of moles of a solute in 1 liter of the solution. Okay, so the value is you can say defined here. The solution should be in liters at any given temperature. That means molarity depends upon temperature. Very important thing here. This question is asked many times in the exams, that molarity depends on which terms, means on which factors. So it is depending on temperature. If temperature changes, then molarity also changes. Why? Because we are studying here the, you can say, a type of solubility when the solute is dissolved in a means any solution. Okay, so it depends on temperature. Let's take the formula. The M means molarity is equal to number of moles of solute, that is N, volume of the solution in liter, that is V. So in short we can write like this also, M is equal to N upon V. Okay, this makes our formula easy to understand. And the unit will be of molarity, that is mole per liter. Mole, number of moles, mole per liter, that is solution. Let's understand the molarity with the more important definition of it, that is what is molar solution. Many times this question is asked, what is a molar solution? So a molar solution basically refers that a solution in which 1 mole of solute gets dissolved in per liter of solution, means in the 1 liter of the solution 1 mole is dissolved in 1 liter. This kind of solution is called a molar solution. Let's take some terms related to the molarity, or you can say the molar solutions. That is, if any term is represented by M, that is called molar, and it is defined means the how much amount of solute. This term is representing here amount of solute. Okay, the last term. This is the common name and this is the symbols for the solution. So M represents molar, that is 1 mole in 1 liter. 2M means bimolar, that is 2 moles per liter. M by 2 means semi-molar, that is 1 by 2 mole per liter. M by 10 is decimolar, that is 1 by 10 mole per liter. Similarly, we can take M by 100 centimolar, okay, 1 upon 100 mole per liter. Means you can use the prefixes generally, which most of you read in through the books, so that we can use any term here, and that would define the form, means amount of solute here basically, because the solution remains same in liter only. Okay. One more important formula of molarity, if we are comparing that molarity of liquid, means at one time the volume and molarity is this, and second time the molarity changes or the volume changes but the substance is same, then we can relate their molarity and volumes by the formula M1V1 is equal to M2V2. Let's understand this formula by an example. So the question of molarity we have taken is, calculate the molarity of a solution of ethanol in water in which the mole fraction of ethanol is 0.04 and the density of water is 1 gram per mole ml is given. So this is a very important question because here the mole fraction is also involved. Let's take the question. The mole fraction of ethanol, that is C2H5OH, is 0.04. And mole fraction of H2O, so what it would be, there are two components, ethanol and water. So if ethanol is 0.04, the water would be 1 minus 0.04, that is 0.96. So let the number of moles of C2H5OH and H2O, we have taken N1 and N2. So by the formula of mole fraction, it would be N1 upon N1 plus N2 is equal to 0.04, that is the mole fraction of, means N1 means C2H5OH, which we have let here, and for H2O the formula of this mole fraction would be N2 upon N1 plus N2 is equal to 0.96. So by solving these two equations, we would get, if we divide these equations, then N1 upon N2, because N1 plus N2 would be getting cancelled, we get N1 upon N2 is equal to 0.04 upon 0.96. When you solve it, you will get 1 upon 24. Since the density of water is 1 gram per ml is given and the mass of 1 liter would be 1000 gram. The mass of water in 1 liter would be 1000 gram. So number of moles of H2O would be 1000 upon 18. Because of the density is 1 gram per ml and we are taking mass of in 1 liter, so that means we have to multiply by 1000. That is why it is coming 1000. So 1000 by 18 is equal to, when you solve it, we will get the values 55.55. These are the moles, number of moles of H2O in the solution. Let's put this value in the above equation, in equation number 1. When you solve the equation here, that is N1 by N2 is equal to 1 by 24. So we put the value of N2 here and we will get N1 is equal to 1 by 24 into N2 would go in the multiplication. Okay, so the formula would be in this way. N1 is equal to 1 upon 24, N2 will come in multiplication. And we will get the values, that is 1 by 24 into 55.55 from here. And the answer is coming 2.314. That is the number of moles of ethanol. Now the molarity which we have to calculate, that is molarity of the solution. The formula is number of moles of solute upon volume of the solution in liter. So number of moles is 2.314 upon 1, that is 2.314 m. That is the molarity of this solution. So in this way this question is solved. Diagrammatic representation of molarity. The moles of solute upon liters of solution gives the molarity of the solution. After molarity, we are going to study about molality. It is also related with the same term as molarity, just the amount of the solute is taken in gram. It is defined as the number of moles of solute dissolved in 1000 gram of or 1 kilogram of the solvent. In molarity we had the solvent as 1 liter and here we are having as solvent as 1 kilogram. So the unit of the molality is mole per kilogram, and the formula of molality is number of moles of solute upon mass of the solvent in kilogram. So in short we can write molality is you can say represented as small m, whereas molarity is represented by capital M. So small m is equal to N, that is number of moles, upon W, that is mass of the solvent in kilogram. Let's understand this with the numerical, that is a sugar syrup of weight 214.2 gram contains 34.2 gram of sugar. Calculate its molal concentration. So first of all we should have weight of syrup and weight of the sugar present in it. So weight of total sugar is sugar syrup is 214.2 and the weight of sugar present in it, that is 34.2 gram. Both our values are given to us. So for gram molecular mass of sugar would be, the formula of sugar is C12H22O11. When you put these values here, you will get carbon atomic mass is 12. So 12 into 12 plus hydrogen atomic mass is, we take 1, that is 1 into 22, and oxygen is 16 into 11. The total gram molecular mass is coming 342 gram. So number of moles of sugar. Why we are taking this, why we have calculated gram molecular mass? Because mass is given to us of sugar, but the number of mole is not given, because in formula we require number of moles of sugar as solute. So the number of moles of sugar would be, the formula of number of moles is mass given upon gram molecular mass. So mass given is 34.2 gram and gram molecular mass is 342 gram. When you divide these values, you will easily get 0.1. Now weight of water that is given to us is 214.2 minus the weight of the solute in the solution. So we get the solvent weight, that is 180 gram. In kilogram it would be 0.18 kilogram by dividing 1000 here. So the molality of the solution by the formula is number of moles of sugar upon weight of water in kilogram. So number of moles of sugar we have calculated 0.1 and the weight of water is 0.18 kilogram. When you put these values here, you will get your answer as 0.56 mole per kilogram. So the molar concentration of the given solution would be 0.56 m, that is molality. Okay, so in this way we understand molarity and molality easily. Thank you. a diagrammatic representation of molality, that is number of moles of solute upon mass of solvent in kilogram.